Hello, it's IPC Apex Expo 2023 in San Diego. It's the final day. I'm joined by Ryan and Mike from X2F. Thanks for coming over.
Oh, thanks for having us.
So give me an overview, as we haven't spoken before, give me an overview of the whole business.
Sure. X2F stands for Extrude to Fill. We are a technology provider with unique solutions for the electronics sector.
Right.
What we do that's unique is we're able to process highly filled materials and encapsulate electronics that might ordinarily use conformal coatings or pottings.
Ah, right, okay.
And the highly filled materials, a lot of times we say these materials are impossible to mold. They're very difficult to process with traditional equipment, and that's the unique capability of X2F. So these highly filled materials enhance the thermal properties of the electronics and add to the performance.
Okay.
And as you probably know, thermal is a really challenging topic with a lot of electronics getting a lot hotter, smaller, more powerful. And so we see a lot of applications for the X2F technology to improve the performance across a wide variety of electronics applications.
Because there's a lot of hostile environments, and when we say, you think a hostile environment would be something horrific, but it can just be a hot environment or a,
That's right.
A lot of vibration. It's not hard to.
When you have a lot of battery applications, there's a lot of thermal needs with batteries. One of the initial applications we're targeting is what they call the brains of the battery management system, which sits on top of the battery pack, and it can get very hot. And with our approach, we're able to significantly reduce the temperature of the battery management systems, which allows the battery packs to charge faster, run longer, have higher energy densities, and so several benefits for improved performance using materials that go through our systems.
How long does it take to develop these kind of things? Because it's a huge win, and it's a big solution for.
That's right. So it's taken several years. So the co-founder and chief technology officer, his name is Rick Fitzpatrick. He developed this in his garage about 15 years ago. So some humble beginnings, but he designed the systems, cut the sheet metal, assembled the equipment, put together the algorithms, and it's really a combination of the hardware and software that allows us to do this. And one of the things we're doing here at the show is talking to our partners, the material providers that are providing these the specially filled materials for electronics. So working in tandem with the material providers to provide a solution to the end customers.
So what kind of things are you showing them? You've got some quite specific products that you can show them that demonstrate
absolutely.
Things.
Absolutely, we've got a couple
I'm holding a few bits here actually, which
we've got a couple of examples here. So taking a look at this one, this is an example of a highly filled polycarbonate material that's being used to replace an aluminum heatsink and also immold an LED module into the heatsink itself. So backing that up a little bit and touching upon a few of these points a little further, this module is not held down with any attachment hardware. There's no thermal interface material. That board goes directly into one of our cavities in our mold, and then we mold this thermally conductive polymer, this highly filled polymer that's very difficult to process within industry. We're able to mold this within the cavity and have it come out of the part within 20 seconds. This part in particular, 20 seconds or less, I should clarify. So this part in particular, if you compare it to an aluminum counterpart of the same volume and the same structure, it's within a half a degree Celsius of an aluminum heatsink. No thermal interface material again, no attachment hardware, much easier to process. It also brings the advantage of being 50% lighter than aluminum, and much more easy to implement within the end design.
I mean it's it's a hefty piece of kit that, but it's
light.
It feels light. Like you say, and those benefits are huge, aren't they? So I bet people are cramming your
well, it goes beyond these applications because not only are we looking at these hard thermal heat sinks, but we're also looking at overmolding different materials and different PCBs. So it doesn't just stop with immolding. Like we can completely coat the top and bottom side of FR4 boards, copper backed boards, things like that. And dissipate the heat much more efficiently than traditional methods that are used. We look at comparing against conformal coating against potting. Conformal coating doesn't provide any thermal benefit. Potting does provide thermal benefit, but potting's difficult to process. Don't have the value add with the conformal coating. We merge the two, make it much more simple, much easier to drive into the industry and solve a problem that's been there for a while.
Yes, it has, isn't it? So you must be working pretty closely in collaboration with your customers then to come up with these solutions.
Yeah, we do. A lot of times customers come to us with thermal management challenges, thermal management needs, and we work hand in hand with them. We'll do prototyping at our facility, piloting. Sometimes we'll do production at the X2F facility. Other times we'll set up our equipment and technology at their facilities for them to do the production.
Right.
So, but we do work very closely with the customers and the material providers. So that's an important part of the puzzle, is getting these highly filled materials that before X2F they didn't exist in a lot of cases. So they're doing the formulations for our process because there is a need in the marketplace.
Yeah. So I guess it also gives them the ability to reassess their design process as well a bit, because you've got
absolutely
different materials. They can play a bit more, can't they?
Absolutely, we work with a lot of different materials. I mean, different fillers, different percent loading. So there's a lot of different new design capabilities that the customer has within their portfolio to bring to market. And one other thing that makes us a little bit more differential is because we're such low pressure within our system, we're able to use cheap 3D printed molds to do rapid prototyping. Traditional injection molding, you're looking at 40,000, 60,000 plus just to get the mold in house, 8 weeks plus before it even shows up. From the time we get a part, provided that it works within our system, we're able to go from design to parts on the customer's table, ready to look at and use within their design in 5 to 10 days. So it's completely revolutionizing the design side.
So you're ticking all of those boxes. It's speedy, cost effective, and more efficient.
It provides a solution to a problem that's been growing more and more, and will continue to grow as circuitry gets smaller and heat becomes higher. We stand ready to provide that solution.
I bet you've had some quite exciting conversations those past few days, haven't you?
Absolutely.
We've found it to be a great conference. It's good to see the energy back after last year, a little bit quieter. So it's fun to see a lot of our partners here, a lot of customers, and develop new relationships as well.
That's good. So what shows you'll be at next? Have you got a plan for other expos in the next year or so?
Kind of taking a look around at different industries and different shows. So your traditional MD&M West,
I see you've got
CES battery show. Like we're working pretty heavily with those battery management systems. So different shows for different industries.
Fantastic. Well, I hope the last few hours of today are busy for you as well. Nice to be able to get a bit of a sit down anyway before we get back to the stand. Great, really appreciate coming over and talk to us, and we'll see you again soon, hopefully.
No, thank you for having us.
Thank you.
Appreciate it.